deal is about the basic concept of local maximum and local minimum. Local max and local min, they have another names. So local max is the same as relative max. Local min is the same thing as relative min. So when we analyze local max and local min, one thing that you have to look at is the slope. So when I want to find the slope of a function, what do you find? You have to tell me the first derivative, f prime, right? So for slope, how do you get a local maximum? So think about roller coaster. So going up, going down, going up, going down, right? How do you find local maximum? What is a local maximum looks like? Local maximum looks like a hill, right? A parabola that is facing down. So local maximum looks like this. So using the slope, so first the slope has to be going up, right? So the slope is increasing, the slope is positive, and then we reach to the top of the mountain. That means at the top of the mountain, the slope is equals to 0. So therefore, we have a horizontal tangent. And then as after we pass the top of the mountain, the slope is going down. So going up and then reach to the top and then going down. So that gives me a maximum. What about minimum? Minimum is going down and then you reach to the bottom of the mountain. So at that point, we have a horizontal tangent. The slope is equals to 0. And then we go up. So we have down, 0, up. So this gives me a minimum. All right. So other than that, and then at this point, the top of the mountain, just think about this parabola. At this point, we have a maximum, right? So think about this parabola. At this point, we have a minimum. So at the maximum and the minimum, the slope is equals to 0. At the max and at the min, we have a horizontal tangent line touching the max and touching the min. So at that point, we have a name for it. So at that point, we have a critical number. So what is a critical number? Here is the definition. Definition of critical number. A critical number of a function f is a number c in the domain of f such that either f prime of c is equals to 0, f prime c equals to 0. What does that mean? F prime c equals to 0 means we have a horizontal tangent. Or f prime c does not exist. So f prime c does not exist means the function is not differentiable at point C. So not differentiable, usually we have a sharp point or we have a cups. Other than that, we can have a discontinuity, right? So usually when we do min and max, we have to deal with the sharp point and the cups. So what is a sharp point and the cups? So let's draw a couple more pictures. Local maximum, give me a local maximum. So f prime c equals to 0. Can you draw a picture for me? Yes, I am going to draw a parabola that is upside down. So at this point, we have f prime of c equals to 0. So when x is equals to c, at that point, the slope of the function is equals to 0. So therefore, we have a max. What about sharp point? Sharp point, you can think about the graph of a upside down absolute value, something like that. So this is a sharp point, and then this is also a max. So we have increasing, and then a sharp point, and then decreasing. We have a max. What about a cups? A cups looks like this. So we have this and this. So this is also a max. We call that a cups. What about minimum? So minimum, we can have this. So this is a minimum, right? And then this, and then this. All right, so this is a min, this is a min, this is also a min. They are all local minimum. All right, and then what about those points? The points I put on the graph. What is the name of that point? At that point, we have a critical number. Okay, moving on to more graphs. So I have two graphs right here. Can you tell me where the local max and where the local mins are? So this one, the first one on the left, we have a maximum, right? So we have going up, and then we reach to the top of the mountain, and then at this point, we have a horizontal tangent, and then we go down. So this is a local maximum. Let's call this L max, local max. Another word of local max is relative max. And then this, we go down, and then we reach to the bottom of a mountain. at that point, the tangent line is horizontal. And then after we pass that point, the slope is going up. So this is a local minimum. Let's call that L min. All right. What about the second graph? Where are the maximum? So we have up, and then we reach to the top of the mountain and then down. That is a max. One more right here, up. We have a horizontal tangent and then down. So this is a local max. This is a local max. And then what about local min? Local min, we have a point right here. We have a point right here. So going down, horizontal tangent, going up, going down, horizontal tangent, and then going up. So this is a local min, and then this is a local min. And then this is an arrow. That means the graph keeps going all the way to the left and then all the way to the right. And then let's take a look at two more. How about here? Where are the max and min? So go up, 0 down is the max, so which is right here and then right here. So at this point, we have a maximum. This one, we have a maximum. So that is local maximum. That is a local maximum. And then at this point and this point, going down, 0 and up. So at this point, we have a horizontal tangent, local minimum, and local minimum. And then what about the last one? The last one is a special problem that I create for you. So we have two sharp points, one right here and then one right there. So this is a local max, and then this is a local min. And then we go up, we have a horizontal tangent, and then we go down. So this is another local max, and then this point we have a cups, right? So this is a cups. And then the first 2 points, they are sharp point. And then this point is a local min, and then that's it. So that is the end of the video. So in the next one, I will show you absolute maximum and absolute minimum.